Welcome to this module. I am Dr. Mariapresenti, working as an assistant professor in mathematics, Nirmala College for Women, Coimbatore. In this module, I am going to give the basic information about the graph theory. Graph theory is relatively a new area of mathematics and it was first studied by the famous mathematician Euler in the year 1735. Basically, a graph is made up of the collection of dots and it is called as vertices, and the lines connecting those dots are called as edges. Say for example, in this diagram, C, B, F, A, E, D. These are all dots. So these are called as vertices and the lines connecting all these dots are called as edges. Next is the definition of a graph. A graph is an ordered pair G is equal to V, E, and it consists of non-empty set V. So V is called as vertices and the set E. E is called as edges of two element subsets of V. Next is an adjacent graph. Two vertices are adjacent if they are connected by an edge. Two edges are adjacent if they share a vertex. So the example is shown in the diagram. Next is the bipartite graph. A graph for which it is possible to divide the vertices into two disjoint sets such that there are no edges between any two vertex in the same set. So the example is shown. So AC and BD are not connected. Next is the complete bipartite graph. A bipartite graph for which every vertex in the first set is adjacent to every vertex in the second set. So if my graph is of this form, we call it as complete bipartite graph. Next is complete graph. A graph in which every pair of vertices is adjacent. So in this diagram, we can see A, B, C, D all are adjacent. Next is the connected graph. A graph is connected if there is a path from any vertex to any other vertex. So we call it as connected graph. Next is the degree of a vertex. Number of edges incident on the vertex, we call it as degree of vertex. So for example, for the vertex 1, the degree is 1 because only one edge is incident. So for vertex 0, that we don't have any edge, so the degree of vertex is equal to 0. Likewise, we can find the degree of vertex for each vertex. Next is the Euler path. An Euler path is a path that uses every edge of a graph exactly only once. So in this diagram, we'll start from 4, 4 to 3, 3 to 0, 0 to 1, 1 to 2, 2 to 1. So if it uses every path exactly once, we call it as Euler's path. Next is the Euler's circuit, an Euler's path which starts and stops in the same vertex. So the starting point and the ending point will be the same. We call it as Euler's path. So the example is given. You can compare with the diagram. Next is the multigraph. A multigraph is just a graph but can contain multiple edges between two vertices as well as single edge loops. So the example is shown here. Next is the walk. A walk in a sequence of vertices and edges of a graph. So edges and vertices both can be repeated. So edges also can be repeated and the vertices also can be repeated. So in this diagram, 1 to 2, 2 to 3, 3 to 4, 4 to 2, 2 to 1 and 1 to 3. We call this as a walk. Next is a trial. Trial is an open walk in which no edge is repeated. So vertex can be repeated. In trial, the vertex alone can be repeated. Here, I have given two examples in the same diagram. You can just check it out. Next is the circuit. So in circuit, Vertex also can be repeated, but the edges cannot be repeated. So in this diagram, you will check with the path 1 to 2, 2 to 4, 4 to 3, 3 to 6, 6 to 8, 3 to 8 to 3, 3 to 1. So we call this as a circuit. Next is the path. In a trial in which neither vertices nor edges are repeated, that is, if we traverse a graph such that we do not repeat a vertex and nor we repeat an edge. As path is also a trial, thus it is also an open path. So here in path, vertices should not be repeated and edges also should not be repeated. So the example is given by the diagram. That is, we'll start with the 6, vertex 6, 6 to 8, 8 to 3, 3 to 1, 1 to 2, 2 to 4. So we call this as a path. Next is a cycle. So in cycle, vertex should not be repeated, edges also should not be repeated. Traversing a graph such that we do not repeat a vertex nor we repeat a edge, but the starting and ending vertex must be the same. So to form a cycle, I have to start at a point and finish at the same point. So that's why the starting and ending vertex can be repeated. All the other vertex and edges should not be repeated. So in this cycle, I'll start from 1 to 2, 2 to 4, 4 to 3, 3 to 1. So 1 is repeated twice because the starting and ending vertex should be the same. Thank you.